Welcome to solverfy.
Okay, so basically we have a stick here with a mass on it here. And that mass has a force downward, and that's the force of gravity. The rotating point of the stick is going to be where you're holding it with your fist over here. And we know that in order to hold it steady, the net torque has to be 0. So the torque that your hand exerts on the stick has to be equal to the torque that the mass of the ball is pulling down with. So basically, we know that torque is equal to the force of gravity times the distance to the rotating point. And that, yeah. So you gotta remember these are vector quantities, and that's a dot product. Those are big words. What you gotta remember is you gotta look at two ways of looking at it. You can either look at the component of the force that is perpendicular to the position, which means basically you could look at, okay, if this is the rotating distance to the rotating point, then we would need to look at this component of the force. Now, the way I like to look at it is say, okay, this is the force, this red arrow here, but I'm going to paint over blue to make it really obvious. That's the force. And the distance to the rotating point is actually the component of that position vector that is perpendicular to the force. So it's that. So basically, if you want to minimize the torque you need, the only thing you can really change is this distance here. So basically, you could minimize it by putting this up higher, so like holding the stick straight out up here, or straight down like that. But as soon as you go into the middle, that's when the torque you need becomes greatest.